Hi, welcome to the presentation of the upgrade of Trunk Road 1 Section 1 in Valwater in the Western Cape from stake value 21 to stake value 24. In the agenda, I will be giving a short project description, then I will head into all the existing infrastructure. We will also look at the design process that I followed, and then I will conclude. So Trunk Road 1 is a vital road between the Oudtshoorn and George areas, as this provides access to all the neighboring farms and towns. The terrain or topography within this area is quite hilly. It also has moderate to dry climate region, so temperatures on average ranging between 25 and 30 degrees. Geology in the area, the soil is very clay-like, so this leaving stormwater facilities to often fill up with silt and sedimentation. So the current cross section of the road is a two-way, two-lane road, and these are pictures of existing infrastructures along the section that I'll be upgrading. So if we look at the bottom left picture, we can see cracks on the road. We can see the road losing its skid resistance, as well as some of the road shoulders which has deteriorated. Heading over to the picture in the middle, we can see culverts filled with silt and erosion. On the bottom right, we have overhead lines, so this providing electricity and communications in the area. And in the top right, we have the existing posted speed along the route that I'll be upgrading. So jumping straight into the design process, I found information on the Western Cape Road Network information system, where I found the average daily traffic of the current section of my road section between stake value 21 and 24. In using that information, I was then able to calculate the total EATs of that section of road, which came out to values that I've calculated in the report. I was also given information data, so CBR data, the rain survey data from a company called Zutari. And for the pavement design, I then used the given CBR data, where I then took the EAT calculation as well as CBR calculations to then get the pavement class, get the subgrade class, which, as we can see here, the road section is divided up into 3 subgrade classes, SG3 all the way to SG1. And further information of that can be found in the report as well. Then, based on the road class category total EATs, I was then able to look at TRH4 and then get the pavement classes from there. So I found 3 possible options: a granular base, a hot mix asphalt base, and waterbound macadam base. And then based on those, I've decided to go with the granular base as my final option, which can be showed in the pavement structure for the 3 different subgrade areas of the road section. And I've decided to go with a granular base because it's a much cheaper option, and I'm sure it's a bit more economically friendly. So jumping straight into the actual alignment design for the road. So between stake value 21 and, or rather kilometer 21 and 24, the section then consists of 3 horizontal curves, which are all in line with TRH's minimum requirements and with a maximum super elevation percentage of 3%. And to generate that, I've imported the or referenced in the terrain and the road survey. So then using and creating the geometry tab and using complex by PI to actually go and create that road alignment, and also trying to stick to the center line or the existing center line as close as possible. Then next step was to create the vertical alignment. So setting the terrain active, we can then find the natural ground line. So then also under the geometry tab, under the vertical section, then using complex by VPI to go and create that alignment, and just trying to stick to the natural ground line as much as possible. And this I then ended up with 7 vertical curves, and this also falls within and meets, or rather all the minimum K values and sight distance requirements as well. As part of the design, taking the current existing infrastructure from a two-way two-lane carriageway, I then decided to add a verge in as part of the cross section. I have 2 lanes in both directions, as well as some road shoulders, excuse me, some curbs and channels to then protect the sidewalks that I have over there. Then based on the cross section, then generating the corridor template, which was done by going to the corridor file and then create template. So then adding all those simple elements, and then also making use of the pavement structure that I've decided on to go and actually create all those detail in here, which then comes in handy when generating your quantities for your road section. After all of that, I've then, after the template creation, creating the corridor, it's then creating the long section and cross section generation. So then using the named boundary tool, or tab rather, to then go and select whether I want to create a long section or cross section, and all these drawings can be found as annexures in the report, which will then have more detailed information of what the road actually looks like in terms of horizontal, vertical, and cross section. So as previously mentioned, when I discussed the horizontal alignment, a max of 3% super elevation was used for the design. So this over here then shows that super elevation view. So going to your corridor tab under super elevation, then creating super elevation sections and super elevation lanes, and then it runs all that information with your transition curves and all of that, and this is what that super elevation actually looks like. And then also based on the template, which then has 2% cut and fill slopes, and based on what the vertical and horizontal does in the active terrain, I was then able to extract cut and fill volumes by generating the quantities report, and we can see those total volumes over there. Looking at the drainage aspect, as previously mentioned, I've added in sidewalks and verges as part of the design. So obviously that then allows for stormwater, as I've put in channels, stormwater runoff. The verge then also helps for a nice natural channel for that stormwater to run off into. However, as part of my design, or existing infrastructure will be upgraded just to accommodate the larger amount of stormwater volumes that the new road now will carry. And then looking at this table, this just a brief overview of all existing stormwater infrastructure that we can find in the area. So major culverts all the way to earth drains, to concrete side drains. So that's just to name a few of all the drainage elements that will be touched on. In conclusion, I've decided to go and upgrade this road. As previously seen in the images, the road has reached its life expectancy, this needed for the upgrade, but also ensuring that the design that I came up with can be both suitable for motorists and not motorists, and making it safe and economically friendly. Thank you.